Hello. Welcome to our next chapter. That is your chapter number 2 in AFM. In 50 pages notes we are using. That is your risk management. See, this is all what the chapter is. Everything that you see on the screen, there is nothing more to this chapter. Quickly, we will go through this. Let's see how many marks does this chapter come from. Okay, so look, half page. I will take your 5 minutes and you will get another 4.5 marks in AFM. Got it? So let's start. So basically, this entire chapter revolves around risk management. That is your value at risk. Okay. So let's understand first what value at risk is. So value at risk is basically what is the potential loss that you can have because of an investment. So what do you mean? This loss can spread over days. Basically, if you see any share has a range that it varies. Say for example, your Bharti Airtel share moves at max 2 to 3% in 1 month at max. So if I've invested 1 lakh rupees, what is the risk? My risk for that particular month would only be 2 or 3% because it only moves that much. Basically, my standard deviation is what my risk is. That is what this entire chapter is about. The more the stock fluctuates, the greater is the risk. If I have invested 1 lakh, it is potentially possible that my entire 1 lakh is gone. It is possible, but it is not accurate because my share does not move only by that much. So therefore, my value at risk is only 2 to 3%. That is how much the share moves. Okay. So value at risk, that is the potential maximum loss under adverse scenario. It is the potential maximum loss under adverse scenario, and that is measured through standard deviation. During our entire AFM, whenever somebody says risk, it is standard deviation. Okay, so whenever we have to measure risk, it is measured through your standard deviation. I hope everybody knows this symbol. Perfect. Next is your confidence level. Okay, so we will be learning two new things here. First is your confidence level, and second is your Z score. So confidence level says how sure we are about a prediction or an estimate. How sure we are about a prediction or an estimate. Sir, what do you mean by this? Okay, I will give you two sentences. Okay, my sentence number one is there is a 90% probability that it will rain tomorrow. Okay, this is my sentence number one. My second sentence, I am 95% sure that it will rain tomorrow. You see the difference between both of these sentences? Tell me. In this case, in the first sentence, I am putting the probability. I am putting the 90, let's keep it 95% probability on the rain, that there is a probability whether it will rain or not. This 95% over here says whether it will rain or not, the probability of it raining. In the second sentence, when I say I'm 95% sure, this 95% talks about my confidence. Whatever background working analysis I have done, this talks about my confidence as to how confident I am about the analysis that I have done. The greater the confidence, the closer my actual outcome is to my expected outcome. Got it? So in this case, we are talking about confidence. So therefore, when we say confidence level, it says how sure we are about a prediction or an estimate. Understood? Two values I want you to remember here. If ever the question says there is 95% confidence, so you have to remember the value 1.65, and if the question says there is 99% confidence, then you have to remember 2.33. Okay, 95% is 1.65, 99% is 2.33. I hope everybody is clear with this. Okay, this you have to remember. Perfect. Now Z score. Z score indicates how many standard deviations it is away from the mean value of a population. What does this mean? Nothing I understood. Z score indicates how many standard deviations. Standard deviation basically this, correct? So how many standard deviation it is away from mean value of a population. I will show you. I hope everybody, let's take a black pen. Yes, I hope everybody is aware of what a normal distribution is. Oh, perfect. Beautiful. Great. So this is a normal distribution. So normal distribution basically shows that what is the probability at different points. So normal distribution says that this peak is achieved at a mean value that we call as mu. This is nothing but your mean. So basically, say for example, there is a class of 50 students. If you take an average of 50 students weight, their average say might be at 60 kgs. According to normal distribution, maximum of the students would be around this average. There would be very few students who would be 120 kgs, and there would be very few students maybe who would be at 30 or 40 kgs. But your maximum portion would be around at the near the mean. This is what your normal distribution is. Okay. So this line basically represents your Z score. This line is your Z score. Area under this graph is your probability. So as you can see, probability of being at extremes. In our case, if our mean value say, what did we say? 60 kgs was a mean value. Probability of being at extreme that maybe someone is only 30 kgs and maybe someone is 120 kg, there would be very less number of people. Correct? So this is what your normal distribution is. Now, sir, what is Z score? What does Z score mean? Z score is basically these points. Basically, whatever probability you want to find out. So maybe if you say, in this case, we want to find that, sir, what is the percentage of people? What is the percentage of people who are 70 kgs or less? So my 70 kgs, if my 60 kgs is here, say my 70 kg would be somewhere over here. Correct? Tell me. So I will draw a line. Correct? So this probability is always towards the left. This probability is what Z score helps us calculate. So Z score would be how many standard deviations is 70 kgs away from 60 kgs. If this population that I took, if I calculated that my mean is equal to 60 kgs and my standard deviation, which we call as this, is equal to say for example 5 kg. There is a standard deviation of 5 kg. So our Z score would be 2. How did I calculate 2? Because this Z score that we are calculating for 70 kgs. 60 and 70 has a difference of how much? 10 kgs, which is nothing but 2 standard deviations because our standard deviation is 5 kgs. Correct? So therefore our Z score would be 2. So Z score just talks about how many standard deviations is my line away from my mean. Clear? Great. So let's understand the formula. So formula is, first we are calculating value at risk for X number of days. We are doing it on a day wise. So VAR for H days is equal to, first would be your amount invested. Of course, the more amount you invest, the more value would be at risk. Second is your daily standard deviation. Basically, daily, how much does your stock price fluctuate? That is your standard deviation. Next is your confidence level multiple. That is, what is the confidence level you want? We want, because say for example, if we calculate that, sir, you will never have loss of more than 1 lakh in say 7 days. If you want more percentage, this amount will also increase. That, sir, there is no way that you can have 15 lakhs of loss. Okay, so therefore, if you see, as the percentage increases, its equivalent value also increases. So the more confidence level that you need, the more would be the value at risk. Great. So this is your value at risk, and fourth would be your root x. That is your number of days. Let's solve a small question, and we should be easy to go through. First, share investment is 1 crore. We've got amount. Okay, price standard deviation is 2% per day. That means your stock fluctuates 2% on an average daily. There are 250 trading days a year, and the confidence level that we are seeking for is 95% confidence. That means we want to find out one figure which will be correct in 95% of the cases. So this is the confidence level we want. And what would be the maximum loss for 10 days? This is your X. Okay. So 1 crore, we have 1 and 7 zeros. I hope everybody knows 1 crore has 7 zeros. Okay. So we did 1 crore into 2% into this 95% that we saw here, that is 1.65. So we multiplied this by 1.65 and multiplied by root 10, that is your number of days. You will get a figure of 10,43,551. Sir, what does this mean? This means that in 95% of the cases, you will not have a loss of more than 10,43,551. What did I say? Repeat. In 95 cases, you will not have a loss of more than 10,43,551. Understood? Sir, if this was not 95%, if this was 99%, what would be the calculation? Everything would be same. Instead of multiplying it by 1.65, we would have multiplied by 2.33, and this amount would have been increased. So therefore, then our statement would be, in 99% of the cases, you would not have a loss which exceeds so and so amount. Understood? Are you sure you understand confidence level now and that score? Okay, great. And next is the same formula if we want to calculate monthly VR instead of for daily VR. So in this case, what do? You do amount invested into yearly standard deviation into confidence level multiple divided by, over here, this is not a typo, it is actually divided by root 12. Why it is different? Because over here, when you are calculating for X days, you were using daily standard deviation. Correct? When you are calculating day wise, you are using daily standard deviation. Over here, when you are calculating month wise, since over here we have done yearly standard deviation, so we will be dividing it by root 12 here. Rest everything remains the same, logic remains the same, confidence percentages remain the same. Remember, 95% has 1.65 and 99% has 2.33. This is something that you have to remember in this chapter. Okay, with this we are done with this chapter. I hope it was easy. Any doubts, put it in the comment section, and I will see you in the next chapter. Bye bye.